In this video, we're going to talk about graphing piecewise functions. It's going to be somewhat similar to how you might have graphed a standard function. It's going to be a little bit more exotic, though, in how we approach it. So let's go ahead and just talk briefly about what a piecewise function is. So a piecewise function is a function that's made up of different functions. That makes sense. So for this example, f of x is equal to x plus 3 only when the inputs x's, right, are less than 1. F of x is also equal to negative x plus 3 when x is greater than or equal 1, or when my inputs are greater than or equal 1. So they're going to look a little bit more elaborate. I still enjoy using table of values to create a graph for these functions. So let me show you how you might do that one way. So I've set up some tables here for us and some graph paper as well. Let's walk through one method you might use to graph a piecewise function. So I have each piece of the piecewise function from before laid out for us. So if you can remember, f of x is equal to 2x plus 3 when the inputs or the x's are less than 1. And f of x is equal to negative x plus 3 when my inputs or x values are greater than or equal 1. So when I go to create my table of values, I'm choosing my x values, right? It's not given to me here. I'm going to choose values that are less than 1, at least a few, right? You might notice that this function here, right, f of x is equal to 2x plus 3, it looks familiar, right? You might be thinking linear equation stuff, right? Y equaling mx plus b, our slope is 2, our y-intercept is 3. Some of that stuff might be coming to your mind. And so when we're graphing a line, we really only need 2 points. So I'm going to go ahead and pick some points that are less than 1 for us to evaluate into this. My favorite value to plug in, 0, that's a good one. I'm not going to get too exotic. I'm just going to pick negative 1 for another value. And so then this next part, it might feel odd that I'm going to do this, but I actually choose the boundary value. I know it says x has to be lesser than 1, but I'm going to kind of imagine, what if x could equal 1? What would come from that? So I'm going to go ahead and add that to our table to evaluate here. All right, and so now that I have some x values chosen, I'm going to go ahead and just plug these in with you. So I want to plug in the x value of 1 into this function. I'm going to plug it in wherever there was an x. And then simplify. So 2 times 1 is equal to, if I add 3 to 2, I get 5. Great. All right, so let's keep moving here. I'm going to shorten this a little bit. I'm just going to plug in 0 wherever there was an x. Anything times 0, even 2, is equal to 0. And then if I add 3 to 0, I get 3. Okay, so last one together. Negative 1 into all of the x positions. 2 times negative 1 is equal negative 2. If I add 3 to that, I get, is that 1? Hope you're working along with me. You can check your work as well. All right, so I'm going to go ahead and, since we're already kind of thinking about this guy, the 2x plus 3, let's go ahead and graph it here. And then we'll move on to filling out the table for the next function as well. So bear with me here. Let me go ahead and plot my first point when x is equal to 1. We found that the output is equal 5. So I'm going to go here to x equaling 1, and then I'm going to go up to where the output is equal 5, and I'm going to plot the point right here. And oops, let's see, right here. And oh, actually, before we do that, let me go ahead and erase my mark, right? Because we have to remember, it should feel kind of odd that I'm choosing 1, right? Because this specifically said that the interval is less than 1. So what I'm going to do is do an open circle here, right? Remember the open dot or open circle, that indicates that that graph doesn't actually exist there, right? Okay, so let's keep going. The next x value we plugged in was 0, and the output was 3, right? Our y-intercept, you might have noticed that. Okay. And then the last one we have here is x equaling -1. The output is +1. So we're right here on the other side of the x-axis. All right, so for this guy, if I wanted to trace it, I could. It's going to look kind of like this, right? Not a great line, but I'm sure you can imagine it. And then it keeps going off in this direction, just as it's behaving this way, right? Because any inputs less than 1 are going to continue to behave this way. Okay, with that being said, take a deep breath. We're going to go ahead and choose some x values to plug into this function over here, -x plus 3. So these x values need to be greater than or equal 1. So we can definitely choose some values that are greater than or equal 1. If I can, one of my other personal favorites to plug in is 1. So I'm definitely going to be choosing that. Makes things nice. And then if you notice, I'm going to just choose 2. Here, -x plus 3, it might look familiar. That's a linear equation. And again, when we're plotting lines, if we remember this, it's really helpful. We really only need 2 points, right? So let's go ahead and evaluate 1 into this equation, right? So f of 1 here is -1 plus 3. I just plugged in 1 wherever there was an x, and then I simplify. -1 plus 3 is equal to. Okay, so now let's try when x is equal to. When I plug in 2 for my x, I get -2. Oh, that's a weird plus sign. You know it is. Plus 3. Okay. And so now if I simplify this, right, I get -2 plus 3, which is equal 1. Hopefully I've done that correctly. All right, let's go ahead and try to plot this guy. This down here on this graph paper. So we have x equaling 1. The output is equal to. So I'm going to go right here. Next step, and that was a solid dot, right? Because x is greater than or equal 1. Next step is x equaling 2, and the output is 1. So we're here. And then let me go ahead and emphasize this is that closed dot. And then again, our line just continues on as x grows bigger and bigger, just kind of off in this direction. I'll try to make a better line than I did the first time around. Oh, that looks beautiful. Okay, so that is the graph for this other guy. So we were able to graph 2x plus 3 with some values. It looks like this. We were able to graph the -x plus 3 down here. So what we would want to do with a piecewise function is graph it all in one, right? And so maybe you've already done that, but I just wanted to point out that this is what the 2x plus 3 looks like when x is less than 1. I even did the open dot for us. And then this is what the -x plus 3 when x is greater than or equal 1, those inputs. That's what the graph looks like here. So what we're going to try to do, and I don't know if I could be clever enough to just copy this over, so I'm probably going to have to redraw it. I'm going to take this graph and put it all together in one neat little package. So let's go ahead and try that out if you haven't done it already. So from the original graph, the 2x plus 3, we had our open dot here at x equaling 1, comma 5. Sorry, y equaling 5. And then our y-intercept again was here. And then we kind of had a line that just kind of continued on in this manner. If I can draw straight, for some reason this one's really challenging for me. All right, hopefully you're doing great on your own there. Okay, so that was the 2x plus 3 portion on this same graph paper, right? Let's go ahead and graph out the negative x plus 3. The first point that we had was x equaling 1. The output was y was 2. And the y value was 2. And then the next point was x equaling 2. And the corresponding output was 1. So we're here. And I'm going to really emphasize this, right? This was a solid dot. And then this graph, because we noticed that it was a linear equation, and we know it just kind of continues on behaving such off to infinity, right? And we put the little arrow to indicate that. So this is one method you might use. It might seem kind of like I've overdone things, right? Kind of creating these individual table of values, its own graph, right, for each one of these, and then combining together. But sometimes, especially when these get really complicated, it can be helpful, right, to kind of just slow things down, do things step by step. We know how to graph functions, right? We can create table of values. Even though we're not being prompted to do it, it's a good, useful tool for us to try this out. So I have another piecewise function for us. What I want us to do is have you go ahead and pause the video and see if you can graph this function. Just take a few seconds and just do your best, and we'll see how we do. Okay, so let's go ahead and graph this together. I went ahead and created the table of value ideas for us. And then I actually just have one piece of graph paper here for us to try this on. I'm going to try a little bit of a different method. We'll see how it goes as we work along. It might be a little shortcut for us. So again, we don't have values yet for our x's, our inputs for each one of these table of values. We're going to come up with those depending on our interval, right? So, or our inequality. So here, I want to choose inputs for this function such that they're less than -2. And if you remember from before, even though it felt odd, right, I chose -2, or I chose the boundary value, right? And I'm going to do the same here because I kind of want to know what would happen if I plugged in -2. And if you're familiar, this is not linear, right? This function here is not linear, so I might need a few more values to get an idea of what that shape looks like, right? Okay, so I'm going to go ahead, what's less than -2? -3 is, and maybe we'll do -4. Hopefully that's enough for me to get an idea of what this looks like. So let's go ahead and try plugging these in to this x squared plus 2x minus 5 portion. And so especially since all of these x values are negative, we'll get good practice plugging in negative values into a function that squares things, right? This is really important. And I'm probably going to run out of room. I'm just going to go ahead and maybe I'll talk us through what this equals. So hopefully you're working along with me if you haven't done this already, and so you can verify my answers. So here for this first guy, I have -2 squared, and the reason I wanted to make sure I put it in parentheses is I want to really emphasize the idea. We're multiplying -2 times -2. And we should get a +4. So this guy is another complicated way of just saying +4. Next up, we have this 2 times a -2. So here, if I just had 2 times 2, I know that would be 4 as well. but I know that one of these is positive and the other is negative. So 2 times a negative 2 is equal negative 4. If you remember or you have it written down, where are we at? What's the score? I had 4 here. I'm taking away 4, so I'm at 0. All that's left is to take away 5 from that 0, so the answer is -5. Hopefully that made sense. Sorry I ran out of room for this, but hopefully you're working along with me. Okay, next up, -3 squared, making sure to put it in parentheses, plus 2 times -3, and then -5. Okay, so again, -3 squared, that's +9. 2 times -3, that's a -6. So 9 minus 6 is 3, and then 3 minus 5. Ooh, what is that? -2? Okay, crossing my fingers, I'm doing the arithmetic okay here on the video. All right, so let's go ahead and try the last x value, -4. -4 squared plus 2 times -4, and then take away 5 at the end. Okay, so -4 squared is equal 16. 2 times -4, that's -8. So 16 minus 8, 16 minus 8, that's going to be equal 8. And then 8 minus 5, I think that's equal 3. Okay, let me write that down before I forget. Whoops, that is a silly looking 3. Hopefully that comes across as 3 to you. Okay, let's go ahead and try this next function here in the middle before we graph. Let's go ahead and pick some x values that fit within this inequality. So the eagle-eyed viewer, they might notice that 3x plus 4, that is a linear equation, or the equation of a line, right? And we only need 2 points to plot, to graph a line. Let's go ahead and pick our boundary value for x, -2. And even though it feels weird, right, I'm going to pick this other boundary, right? Again, with the caveat of I can't actually be there. There's going to be an open dot kind of thing. Let's make sure we remember that, but I think it's helpful to know how it behaves as it approaches 1. And in fact, you know what? Let's go ahead and plug in a 0 in this as well, because 0 is there in between -2 and 1, and I love plugging in 0. It's easy. Okay, so let's start by plugging in our -2 into this. All right. So everywhere there's an x, I plug in -2. I get -6 when I start to simplify, and then I add 4, and I get -2. Okay, now plugging in 0 is my favorite. All right, 3. I'm not really good at 3s these days. 3 times 0 plus 4. Well, 3 times 0 is equal 0, and if I add 4 to 0, I am left with 4. So pretty easy. Okay, the last one. 3 times 1 is equal 3, and if I add 4 to 3, I get 7. Okay, appreciate you sticking with me here. The last one we're going to do is this guy over here. F of x is equal to 7. Here, we're going to pick values greater than or equal 1, so you know 1's going to show up. And then maybe I'll pick a couple other values too. So definitely 1. I'm not going to go too wild. I'll do 2 and 3 as well. So this part can feel kind of interesting, right? Because I'm sitting here and I'm thinking, all right, I'm going to plug in 1 into this function. And what's my output going to be, right? I plug in 1, let's see that notation. And then anywhere there's an x, right, I'm going to plug in that 1, but there's no x on that side, right? So it's just equals 7, right? So a word of caution, these can be kind of weird and confusing, but since there is no x, right, we don't have to plug anything in. It's just going to be equal 7. Anytime we plug anything in that's greater than or equal 1, the output is going to equal 7. That's going to be a horizontal line when we get to graphing, but it's definitely one of those things that can kind of trick us, right? Okay, so see how this will come across on the screen. We saw the method before when we were graphing these things. I created the table of values, and I definitely suggest doing a few values at least to see what's going on. And so let's go ahead and try to put all of these things together on one graph paper. So if you haven't already, I'm going to start over here. Maybe you can start with me as well. The first x value that I had picked was -2, and the output was -5. So that's going to be down here. And then the next value, we're going to the left, right, because we have -3 as the input value for our x. And the output is equal -2. So that's going to be right here. And then our next value is going to be -4. And the output is going to be equal 3. So we're going to be up here. Interesting. Okay. All right. Oh, and then a point here. You know, I really should start putting stars next to these boundary values. So maybe that's a system that we should put in place here. I talked a big game like I would remember this, and I almost forgot again. So here, remember that -2 actually isn't included in this, but I said I needed to do this because I want to see what's happening as I'm approaching -2. And then I'm also noticing, remember I said 1, that's not included in this, but I did plug it in. So let's go ahead, because I don't want to forget again, I'm just going to put little stars next to those values. Maybe that's going to be a useful thing for me to make sure I kind of pump the brakes a little bit on those when I go to graph, depending on how far into it I get. So let's go ahead and erase. Actually, I want to make sure I don't do a closed dot there at these points. I'm going to do my open dot method. Oops. Okay, this was -2, comma, -5. Looks like an open dot to me. Okay, so before we move on to plotting the next ones, what you might notice, or you'll begin to know, is that this is a parabola, right? It's got a parabolic shape to it. They are very common. So let's go ahead and, again, if you haven't seen this, I apologize, but this is something that we're going to see often in this class, in this term. So it's going to look something like this. I'm hoping it comes across, right? It's a kind of a curvature shape. Parabolas are generally going to be concave up, so like this in the top left corner of your screen, or concave down. So it's going to be a part of one of these guys. I hope that comes across in my drawing, but let's go ahead and try the next function. Right, the next function here was the 3x plus 4. Let's go ahead and plot these points on our graph. So when x is equal -2, the output of this guy was -2. And so I think that's going to be right here. Okay. And then the next value we plugged in was 0. And the output was 4. Okay. And that's going to be up here. Quite the jump. Okay. All right, so then the next input was +1, and the output is equal 7. All right. Here we are. I did it again, didn't I? You'll have to be keeping better track than I am here. I put that star next to it because I wanted to remember there is an open dot there. Cool. Okay. Glad I'm catching myself. All right. So we're going to connect these because we're noting that this is a linear function. It's going to have this wonderful straight line connecting them, just like that. All right, and maybe I'll emphasize the fact that this is a absolute, definitely a closed dot there. Cool. Okay, so if you're still with me, the last thing we're going to plot all together is this guy is the f of x is equal to 7. This was when x is greater than or equal to 1. So we plugged in 1, 2, and 3 and saw this is just a flat horizontal line. And actually it picks up where we left off, isn't it? So I'm going to go ahead. I get to fill in this circle. Here I was worried about that, and that definitely did not need to be worried about because the next function went ahead and filled in. And I could keep going. I know I only plugged in values 1, 2, and 3 into this, but I know that there are other values that I could plug in, and it'll keep behaving this way. So I'm going to put an arrow at the end of this to say that, right? I don't want to sit here all day drawing. It can go on forever in this manner. So these are just a few ways that you might consider doing this. I definitely suggest, at least the first few times that you graph these, take the time to create the table of values, and maybe even take the time to graph the individual functions inside your piecewise function. I think that can be really helpful to see and understand what each of these pieces are looking like, right? All right, thank you for watching. I hope you have a good day.